When people learn basic arithmetic, they learn how to add, subtract, multiply, and divide with whole numbers. Then they learn other math concepts such as fractions, decimals, and percents using that basic arithmetic. In fraction arithmetic, multiplication and division of whole numbers are used quite a bit. For example, when you learn fraction arithmetic, you will be expected to know if 18/24 can be reduced to a smaller form. What would you say, Irving?
I'm not sure. I think it can be reduced to 9/12.
What about you, Bruno? What would you say?
I think so too, but I'd say 6/8.
You're both partially correct. 18/24 can be reduced to those two numbers. But 18/24 can also be reduced to 3/4 in its lowest form. In order to be able to do this, you must know basic multiplication and division of whole numbers, the kinds of things you learn from memorizing this 12 by 12 multiplication table. You were both correct when I asked you if this fraction can be reduced to a smaller form, and it can be reduced to 9/12 and 6/8. But in most cases, you want to reduce it to its lowest form, which is 3/4. In order to be able to reduce it to its lowest form, you'll have to know all the numbers that divide evenly into 18 and all the numbers that divide evenly into 24. All the numbers that divide evenly into 18 are 1, 2, 3, 6, 9, and 18. All the numbers that divide evenly into 24 are 1, 2, 3, 4, 6, 8, 12, and 24. This comes from memorizing the times tables charts, and would be one of the things you'd be expected to know by the time you start learning fraction arithmetic. You must have memorized these basic times tables in order to go on to fraction arithmetic or any other form of math. The problem is that a lot of people never bothered to learn this or forgot it. Now let me explain how to reduce 18/24. In order to reduce this fraction, you have to know if there are any common numbers that divide evenly into the top number and the bottom number. Again, here are all the numbers that divide evenly into 18 and that divide evenly into 24. As you can see, there are several common numbers that divide evenly into both of them, 2, 3, and 6. What you did, Irving, was to divide the top and bottom by 2 to get 9/12. The problem with that is it can still be reduced. Again, in order to reduce it further, you'd have to know all the numbers that divide evenly into 9 and all the numbers that divide evenly into 12 to know if there are any common numbers. 1, 3, and 9 divide evenly into 9, and 1, 2, 3, 4, and 6, and 12 all divide evenly into 12. As you can see, they both have a common 3 that will divide evenly into both of them. So I can reduce the top and bottom number by 3 to get 3/4. Bruno, you said it reduces to 6/8. What you did was to reduce the top and bottom by the common number 3 to get 6/8. Again, the problem with that is that 6/8 can be reduced further. 1, 2, 3, and 6 all divide evenly into 6. 1, 2, 4, and 8 all divide evenly into 8. The common number to both of them is 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. So we wind up with 3/4 again. As you can see, no matter what path we take, as long as we keep reducing, we'll always get to the same final answer. If you look back at the original problem, you'll see that the largest common number that will divide evenly into 18 and 24 is 6. 18 divided by 6 is 3, and 24 divided by 6 is 4. Here we did it in one step. The object is to find the largest number so that you can reduce the fraction in one step. But if you're not able to do that, then you can reduce it in steps to its lowest form. As you can see, there's a lot going on here just to be able to reduce simple fractions.
There certainly is. I should have paid more attention to learning the times tables charts. Me too, I never knew I'd be using that stuff so much.
Well, I've got a chart here that's much easier to use and will help you to learn fraction arithmetic.
I'd sure like to see that.
This is not meant to replace memorizing the times tables, but it will help you to get started with learning to do fraction arithmetic, and hopefully, by using this chart, you will start memorizing basic multiplication and division of whole numbers. Okay, let me first show you the chart, then I'll explain how to use it by actually reducing and raising fractions. Then I'll show you how to compare fractions to see which one is larger and which one is smaller using this chart. Then I'll show you how to use it to find the lowest common multiple when adding fractions with different denominators. I've created 2 pages of divisors and multiples for the numbers 1 through 80. The first page covers the numbers 1 to 42, and the second page covers the numbers 43 to 80. The first set of numbers in black are the primary numbers. The next set of numbers in red are all of the divisors that will divide evenly into the primary numbers. The last set of numbers in blue are all of the 2 by 2 multiples that multiply together to get our primary numbers. Let's take a closer look at the divisors and multiples of 18 and 24, the numerator and the denominator of a fraction we wanted to reduce. For 18, all the whole numbers that divide evenly into it are 1, 2, 3, 6, 9, and 18. The 2 by 2 multiples of those numbers that multiply together to get 18 are 1 times 18, 2 times 9, 3 times 6. Once you have all of the divisors of a number lined up smallest to largest, it's easy to find the 2 by 2 multiples. You take the 2 outer ones together first, 1 and 18. Then the next 2 inner ones, 2 and 9. Then the next 2 inner ones after that, 3 and 6. Now for 24, 1, 2, 3, 4, 6, 8, 12, and 24 all divide evenly to 24. Here are all of the 2 by 2 multiples of those divisors that multiply together to get 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And again, as in our previous number, here's how you get those multiples once you have all the divisors lined up smallest to largest. The 2 outermost ones first, 1 and 24. The next 2 inner ones, 2 and 12. The next 2 inner ones after that, 3 and 8. And finally, the 2 most inner ones, 4 and 6. You can also use this chart for simple division once you have the multiples. As you can see, the divisors tell you which numbers divide evenly into our primary numbers, 18 and 24. But they don't tell you how many times each one divides into the primary number. For that, you use the multiples. The multiples will tell you how many times each number divides into our primary number. Let's say you know all of the divisors like we have lined up here, but you want to know how many times each of them divides evenly into our primary number. For example, you know that 9 divides evenly into 18, but how many times does 9 divide into 18? For that answer, you look at the multiple of 9 to see that it's 2. So 9 divides into 18 2 times, and 2 divides into 18 9 times. And what about 6? You know from the list of divisors for 18 that 6 divides evenly into 18. But how many times does it divide evenly into 18? Well, just look at the multiplier of 6 to see that it's 3. That means that 6 divides evenly into 18 3 times. And you also know that 3 divides into 18 6 times. What about 24? For example, you know from the divisors that 8 divides evenly into 24. But how many times? Look at the multiplier of 8 to find that answer. It's 3, so 8 divides into 24 3 times. And 3 divides into 24 8 times. And how about 6? How many times does 6 divide into 24? Look at the multiple of 6 to see that it's 4, which means that 6 divides evenly into 24 4 times. And 4 divides evenly into 24 6 times. Each of the multiples is also a divisor of its corresponding multiple. So the divisors tell you all of the numbers that will divide evenly into our primary numbers, and the multiples tell you 2 things. They tell you which numbers multiply together to get our primary numbers, and also how many times each of the multiples divides into our primary numbers. So what you have in these charts are all of the whole number divisors of the numbers 1 through 80, and all of the 2 by 2 multiples of those divisors of the numbers 1 through 80. And with the multiples, you also have the divisor opposite that multiple. So you also have a division chart here.
Now let's see how we can use this information to reduce the fraction 18/24. We know that 2, 3, and 6 all divide into 18 and 24 evenly. The largest number that divides into 18 and 24 is 6. We always want to use the largest number we can find when reducing fractions. And if you don't know what 18 divided by 6 is, it's 3. And 24 divided by 6 is 4. You are also expected to know if a fraction is already reduced to its smallest form. For example, can 9/16 be reduced, Irving?
In order to know that, I'd have to know all the numbers that divide evenly into 9 and 16. From the chart, here's all the numbers that divide into 9, and here's the numbers that divide into 16. They have no common numbers in them, so I guess 9/16 can't be reduced. It's already in its smallest form.
That's correct. And in order to know that for sure, you had to know all the divisors of 9 and 16 to know they didn't have a common divisor. Bruno, can 6/15 be reduced?
I'm not sure. I'll have to look at the divisors of 6 and 15 to see. It looks like 3 will divide evenly into both 6 and 15. 6 divided by 3 is 2, and 15 divided by 3 is 5. So 6/15 can be reduced to 2/5.
Irving, can 24/30 be reduced?
I have to look at all the divisors of 24 and 30. I can see that they have 2, 3, and 6 as common divisors, and the largest one is 6. So I'm going to reduce the top and bottom by 6. 24 divided by 6 is 4, and 30 divided by 6 is 5. So 24/30ths can be reduced to 4/5.
Bruno, can 8/15ths be reduced?
I'll have to check. The divisors of 8 are 1, 2, 4, and 8. The divisors of 15 are 1, 3, 5, and 15. They have no common divisors other than 1, so 8/15ths can't be reduced. It's already in its smallest form.
Now let's look at going in the other direction, raising fractions up to a higher denominator. There will be times when you'll have to raise fractions up to a higher number to be able to compare them or add them together. Let's say I wanted to take the fraction 5/6 and raise up the bottom to 18. I have to do two things here. I have to figure out what I multiply 6 by to get 18, so that I can multiply the top to find the top of the raised fraction. In order to do that, using these charts, I have to look at 18. Next, I have to look at all the multiples of 18 to find 6 and see what its multiplier is. You can see that 6 times 3 is 18. So if I multiply the bottom of the fraction by 3, I also have to multiply the top by 3. 3 times 5 is 15. So if I wanted to raise 5/6 to 18ths, I'd have to multiply the top number by 3 also, so that the new raised fraction is 15/18ths. Irving, could you raise a fraction 2/3 to 21sts?
I have to figure out what I have to multiply 3 by to get 21 first. I can see that 3 times 7 is 21. So now I have to multiply 2 times 7 to find the top of the raised fraction. I see that 2 times 7 is 14. So 2/3 can be raised to 14/21.
Yes. One more before we move on. Suppose I wanted to raise 3/4 to 24ths. How would I do that, Bruno?
In order to raise the 4 to 24, I have to figure out what to multiply 4 by to get 24. If I look at 24 in the charts, I can see that 4 is multiplied by 6 to get 24. That means I have to multiply the 3 by 6 also to find the top of the raised fraction. I see that 3 times 6 is 18. So 3/4 can be raised to 18/24.
Yes. Now here's where this new times tables chart really comes in handy. First, I will show you how to compare fractions to each other. Then I'll show you how to use that information to add fractions with different denominators. What if I asked you which fraction was larger, 3/4 or 5/7?
5/7? I'd say 3/4.
Can either one of you explain your answers?
Mine's just a guess. So is mine, Mr. Cox.
In order to compare these fractions to each other, to see which is larger, they have to have the same bottom or denominator. That means that I have to raise the 4 and the 7 up to a number that they will both divide into evenly. Scanning the divisors in the charts, I have to find the first number that has a 4 and 7 in it for divisor. 28 is the first number that has 4 and 7 for divisors, so I'm going to have to raise 4 and 7 up to 28. Next, I have to figure out what I have to multiply 4 by to get 28 in the first fraction. I see that I have to multiply 4 by 7 to get 28, so that means I have to multiply the top of the fraction by 7 also to get 21. In the bottom fraction, I have to multiply 7 by 4, so I have to multiply the 5 by 4 to get 20. I've just raised 3/4 to 21/28 and 5/7 to 20/28. Now all I have to do is look at the top number in both fractions to see which one is larger. 21 is larger than 20, so that means that the original fraction, 3/4, is larger than 5/7. Irving, can you tell me which of these fractions is larger, 5/8 or 7/12?
Well, let me see. I have to look at all the divisor numbers and find the first one that has 8 and 12 in it. 24 is the first number that has divisors 8 and 12. That means that I have to raise up each of these fractions to 24ths and find the tops. Then compare the tops to each other. In order to change 8 to 24, I have to multiply it by 3. So that means I have to multiply the 5 by 3 also to get 15. Next, I have to multiply the 12 by 2 to get 24. So I also have to multiply the 7 by 2 to get 14. I can see that 15 is bigger than 14. So the original fraction, 5/8, is larger than 7/12.
Well done. When you add and subtract fractions with different bottoms or denominators,
You will have to know how to do this. Bruno, can you raise all three of these fractions to a common denominator? Then tell me which is the largest? I'll try. First I have to scan all the divisors and find the first number that has a 5, 15, and 10 in it. 30 is the number that has all three of these numbers in it as divisors. Now I have to raise all these fractions up to 30. If I look at the multiples, I can see that I have to multiply the denominator of the first fraction by 6 to get 30, so the top is 3 times 6 or 18. The second fraction is times 2, so the top of the fraction is 7 times 2 or 14. The last fraction is times 3, so the top is 7 times 3 or 21. The fraction with the largest numerator is the third fraction with 21. That means that the original fraction, 7/10 is the largest, 7/15 is the smallest, and 3/5 is between the two. That's correct. Now let me ask you one more question before we move on. Suppose you had to raise 6 fractions with different denominators up to a common denominator. These 6 fractions all have different denominators, and it would be difficult to quickly find a common denominator for all of these fractions. The first thing I would recommend you do is to line up the numbers smallest to largest to make it easier to find a number with all the divisors. The denominators from smallest to largest are 3, 4, 6, 9, 12, and 18. I showed all the multiples and divisors for the numbers 1 through 30. The number with the divisors 3, 4, 6, 9, and 12, and 18 in it happens to be in the next set of numbers 31 to 40. All of these numbers divide evenly into 36. That means that I have to raise all these fractions up to 36. Now let's finish the problem. I multiply 9 by 4 to get 36, so 5 times 4 is 20. 18 times 2 is 36, so 1 times 2 is 2. 4 times 9 is 36, so 3 times 9 is 27. 3 times 12 is 36, so 2 times 12 is 24. 12 times 3 is 36, so 7 times 3 is 21. 6 times 6 is 36, so 5 times 6 is 30. Now I can find the largest fraction here, which is 30/36. Bruno, which fraction is the smallest? The one with the smallest numerator is 2, so 1/18 is the smallest fraction. Yes. Now that you have an idea on how to use these charts, let's see if we can use this information to add fractions together. The basic rule of fraction addition and subtraction is that the bottoms of the fractions must be the same before you can add or subtract them. In this example, I have to add 2/7 to 1/7. The bottoms are both 7, so I can add them together. The denominator of the answer is 7, and I add the numerators 2 plus 1 to get 3. That example was easy because the denominators in both fractions were the same. But what about this problem? 3/8 plus 7/12. The denominators in these fractions are different. One is 8 and one is 12. Before I can add them together, I must raise both of these fractions up to a number they will both divide into evenly. Using my charts, I find the first number that has an 8 and 12 in it for divisors, which is 24. So I have to raise both fractions to 24 before I can add them together. Looking at the multiples, I see that I have to multiply 8 times 3 to get 24. So that means I have to also multiply the top by 3 to get 9. For the bottom fraction, I have to multiply the denominator by 2 to get 24. So I have to multiply the top by 2 also to get 14. Now I can add them together. The denominator of my answer is 24, and for the numerator, I simply add 9 plus 14 to get 23. So 3/8 plus 7/12 is 23/24. Now what if I wanted to add these fractions together? 2/5, 4/15, and 3/10. Irving, can you do this? It's easy now that I have these multiplication tables. I have to find the first number that has divisors 5, 15, and 10 in it. 30 is the first number that has all of those divisors in it, so I have to raise all 3 fractions up to 30 to be able to add them together. Using the multiples, I see that 5 times 6 is 30 for the top fraction, so the numerator is now 2 times 6 or 12. For the middle fraction, 15 times 2 is 30, so 4 times 2 is 8. In the bottom fraction, 10 times 3 is 30, so 3 times 3 is 9. The bottom of my answer is 30, and the top of the answer is 12 plus 8 plus 9, which is 29, so the answer is 29/30.